Right, okay, this is the second video I'm making, and I'm still on initial value problems, except this is of the second order. Okay, I'm still waiting for that other video to upload, so I might have to put these together. Right, okay, this question, it's like the last question, but there's just an extra few steps in it. Okay, this comes from 2010, which is this question here, part B. Okay, I'll get to integration, I'll keep these together. Right, so how will you know if it's this first order or second order? But for this d squared, this is the real giveaway. Okay, if you're given two initial values. Right, okay, so let's get started. Right, okay. Just give me 2 seconds now. Yeah, so I'll try to get as many of these problems as possible. So this was, what was this now? This was question 5, 2010. Okay, and it's second order, and we were given d squared y dt squared plus dy over dt equals 2t, where t is greater than 0. The two initial ones were y is 0 equals 0 equals equals 0. Okay, I'll make that out. And gy all over gt of 0 is equal to, so I'll have to go on to the next line, and gy of t of 0 is equal to 1. Okay, first of all, this can be written in loads of different ways, so I'll try and get all on the same notation. So just to clear up the notation, this first fella here, that's exactly the same as writing y dashed of t. Okay, that in the green highlighter, which is this and this, are exactly the same thing. Okay, the double dashed here is the same as g squared, and the squared there as well. Okay, so there's just two different ways to write the same thing. So I'm going to stick with this notation. So I'm just going to write all in the same notation first, so don't be scared by it. The next one is just y of t, okay, which is simply, that's the same as 1, which there should be a little dashed here. Sorry now about this. There's my pen. Yeah, there's a little dash there. That's just to show that it's differentiated once. The two dashes here means it's differentiated twice, and the one dash there means it's differentiated once, equals 2t. Okay, and that's really, this is really y of t. Okay, this one here is okay, it's in the right notation. This one here, it's differentiated once, so I'm just going to write it as y dashed of 0 equals 1. Alright, okay, so now the notation is tidied up. Okay, I know this will look messy in the notes, but if you follow along with the video, it should be okay. Right, so I'm just going to go on to the next page and rewrite the equation. And you know what? In fact, I'm just going to drop the of t to keep it simple. Okay, so really this is going to be y of 0. Okay, ignore that. Okay, some things I say in this video I might say them off the top of my head, which might be right. When I go over it again, I'll know, but you'll get the general idea anyway. Right, okay, so I'll just go on to the next page. That's very messy. So what I say, I was going to write y dash dash plus y dashed. Okay, I'm just going to bring this minus 2 across. Okay, it's this fella, I'm bringing him across. Okay, and you'll see why it becomes minus equal to 0. Right, okay, and my initial values are y of 0 equals 0 and y dash dash of, no, it's only differentiated once, of 0 is equal to 1. Right, we're going to ignore these fella to the real end, they're not important to us yet. Right, okay, so for this one with the second order, we have this formula that you need to know, and that is y of x is equal to c1 e to the r little 1 sub 1 x plus c2 r little 2 of x. Okay, right, and this is the formula you need to remember. I'm not sure if it's in the log tables or not. Right, okay, so what we wanted to do, we take, right, you just need to know that. We'll come back to what all of them stand for in a minute. We take this equation, okay, and we just rewrite it like a quadratic equation. Okay, so the first one, if you see a 2 here, that's a little giveaway that that's going to be the r squared. We'll do r squared part, plus if you see the 1 there, that's just going to be the r part. Okay, and we're just going to minus 2 equals 0. Okay, we just dropped the t, right? And all the questions should be like this. So now we have a quadratic equation. So what do you think we would do? Well, we'll solve it. Right, so if r 2 1, what is it, plus minus. Okay, so that'll give us r is equal to 1 and r is equal to minus 2. I presume you're okay with quadratics. Right, okay. Now it doesn't matter what order you do these in, but the first door, this will be your r1 equals 0, and the second door equals, so it's r sub 2 equals minus 2. Right, okay. So now all we do is, now we're going to use this formula here. Alright, so anywhere I see r1 or r2, we're just going to fill them with the answers we got. Right, the only thing we have to change about this is we're dealing with t's here, not x's, so we're just going to replace that x, and that x with a t. Right, okay, so our formula is y of t equals c1 e to the r1 t plus c2. These are to the power of, so it's c2 to the c2 multiplied by e to the power of r2 multiplied by t. Okay, so that's y of t is equal to c1 e to the 1 times t plus c2 e to the minus 2 times t. Okay, you're okay with that? Right. That's our first one. Okay, so these are going to be important. These ones. That fella is important. We'll come back to him. Okay, now we have to find y dash. Yeah, y prime or whatever. We want to differentiate this function. Okay, so we want to differentiate the equation above. So I don't know how you are with differentiation ease. I suppose I'd say you're okay. So if we want to do this, for example, okay, this won't be in the notes. I'll be scribbling it out again. If we do it in a different color. If y is equal to 5 e to the minus 2x dy dx is equal to, okay, we can just ignore that 5 because it's constant. So it's going to be e to the minus 2x, you write it out again, multiplied by, and you differentiate what's ever here. So if I differentiate minus 2x, I get minus 2. So my answer here will be minus 10 e to the minus 2x. Right, in the same way, so here the c1 is like our 5 and the t is like our minus 2x. Right, okay, so we're just going to go on that. So remember, c is just a constant. Okay, I'll just get a rubber and rub this out. So remember, c is just a constant. And again, get back to me if you have trouble with this. Green. So it's going to be c1. Remember, that was like your constant. And you might have to pause these videos if you need to. That was like a constant. So differentiate the e to the t, and remember, we just write out again and multiply it by the derivative of that, which is just 1, plus c2. Remember, that's just a constant. Differentiate e to the minus 2, well, you just write it out again, and remember, we differentiate that and multiply it. Okay, so if I differentiate minus 2, I'm just going to get minus 2. So we write this, that's c1 e to the t plus c2. Sorry. So it's going to be minus 2 by c2, which is, sorry, know about this, so hopefully you're still following. So it's minus 2c2 multiplied by e to the power of minus 2. So that's what y dashed of x is equal to. Right, okay, these are the two equations. This fella here and this fella. Right, so let's deal with the first fella first, which is y of t. Y of t is equal to c1 e to the t, c1 e to the power of t plus c2 e to the power of minus 2, c2 e to the power of minus 2t. Right, and let's start the question. If you remember, we had this, y of 0 is equal to 0. Right, so that means when we sub in 0 in for t in all these, we get 0. So that's what I'm going to do. So this is y of 0 is equal to c1 e to the blah c2 e to the minus 2 times blah. So my blah here is 0, 0, and I know when I work that out, this should all be equal to 0. Right, okay, so this is equal to c1 e to the power of 0, well, answer to the power of 0 is 1, plus c2 e to the power minus 2 times 0, which is 0, so answer to the power of 0 is 1, equals 0. So c1 plus c2 is equal to 0. Right, and that's my first equation. I don't know if you see what's going to happen. We're going to get two equations with c1 and c2. We just do a simultaneous equation and solve. Right. So now that's the first one. Let's do the second one. What was the second one? Y dash of x is equal to c1 let's do the second one. Y dash of x is equal to c1, sorry, it should be t. Y dash t is c1 e to the t minus 2 c2 e to the power of minus 2t. And remember at the start, if you go back to the start, we were told that y dash of 0 is equal to 1. So that means when I put in 0 for these t's, the answer is going to be equal to 1. Right? So I'm just going to do that at 1. So y dash 0 is equal to c1 e to the blah minus 2 c2 e to the minus 2 blah, and I know that answer was going to work out to be 1, so I'm just going to ignore this side of it because I don't need it anymore. Sorry, and my blah there was 0. Okay, so let's work this out. That's equal to c1 times 1 minus 2 c2, and that worked out to be 1 as well because e to the power of 0 is 1. So this c1 minus 2c2 equals 1. And this is my second equation. I know them colours are the same. So now what we want to do is do a simultaneous equation between the first one, which was c1 plus c2 equals 0, and c1 minus 2c2 equals 1. And I'm sure you know how to do simultaneous equation, so I'm just going to change the signs. You might have your own way to do it. They'll cancel, and I'm going to get 3c2 equals minus 1, which gives me 3c2 equals minus 1. 3c2 equals minus 1, so c2 is equal to minus 1 over 3. Now I know that c1 plus c2 is equal to 0, so c1 minus 1 over 3 equals 0. That right? Yeah, so c1 is equal to 1 over 3. Still not finished yet. We just want to get our general equation, which is y of t is equal to, and I'm going back to which one? I'm going back to this one, and all I'm doing is placing the c1 and c2 with what I got. So y of t is equal to minus 1 all over 3 e to the t plus a third times 2 e to the minus 2t is equal to minus 1 over 3 e to the t plus 2 over 3 e to the minus 2t. And that's our answer. Okay, hopefully you followed that. I'll email you on the notes and put the video up on YouTube. Okay.